But what I'm going to do is I'm a millennial whose life is centered around 97, 93. So Pokemon came out in 97. Show hands here. Who's familiar with Pokemon? Cool. Everybody's familiar. Who really lived the life of a Pokemon trainer like when they were young? Okay, all right. So some of this is gonna be a big shock to some of you. Some of you guys are really just still on a lot of these things. But aside from that, I'm also very passionate about the culture of DevOps and how to utilize machine learning for engineering. So again, a lot of this is gonna be about the culture of DevOps, not so much the technical tooling and like specifics of how you implement things. DevOps is a culture. We'll talk about that. So cool. So first, what is DevOps? And so this is a definition, or this definition this is one of the most widely debated topics. If you go online, you kind of look for the definition yourself, you'll find all kinds of different things. It's most DevOps is cultural, and that's why I made them both. Cultural, professional movement, focus on how we build and operate high velocity organizations born from experience and best practice. What does that mean? That's a lot of words. There's a lot of buzzwords in there as well. But DevOps is what you might see when you look at the definition is when you take development, so people who are engineers, software engineers, web engineers, things like that. Operations, these are usually people you know as your sysadmins and people that are managing the servers and the hardware that these things run on. The goal is to really combine them. So there's a fictitious wall in between them historically. Developers develop, they work on a project, they get the task orders, they build the things that they're supposed to build, and then when they're done with it, they take the package, they talk it over to the ops people, and say, hey, deploy it for me. And the ops people have to go try to deploy it and keep it running, in perpetuity, without really knowing much about the application. The goal of DevOps is a cultural shift to really remove that wall and get development closer to operations, and so that one, there's a shared responsibility between developers and operations, so that they both know what's going on. The developers should understand the infrastructure. They should understand how our application is going to be running in production. They should understand how our application fits into the way production is set up, our infrastructure is set up. And operations should understand how the application works. They should be able to get into it, to troubleshoot, to know where calls are being made, to know where to look when issues are happening. And so that's really what the goal of DevOps is. So over here on the left, you see a little infographic. This is one we see very commonly. I think this is also an infographic for Agile as well, but this is an infinity loop, and you can kind of start wherever you want. But we can start with the code here. I don't know if you can see my mouse code. Actually, let's start with plan. You kind of plan out what needs to be done. This is kind of the nature of a project. As you plan it, you write the code for it, figure out what you need. You write that code. Your devs develop it. You build it. You test it. You release it. You deploy it. I don't know what operate one is in here. I don't know what that means. You monitor it, make sure it's good. And this is a feedback loop. You basically change the metrics after you've released it. Figure out if it's what you needed, figure out if it's doing what you intended for. And you iterate on that, and you start the whole process over again. And DevOps is what allows this feedback loop. So next, there's supposed to be what is a Pokemon slide here. Maybe it's too far back. But I think you all know what Pokemon is. Pokemon, Pocket Monsters, made popular in, I think it was popular in Asia before it was popular here. Came out, first episode here in 97 here in the United States. You guys are familiar with the main characters, Ash Ketchum. I don't know what Brock's last name is, Misty Stone. These were your main characters of the show. Pikachu, obviously. You've got, these are basically animals that are out in the wild that you can catch, that you can put into these little magical balls called Pokeballs, and you can train them up and you make a fight. And it's kind of, when you really think about it, it's kind of crazy. It's kind of sick too, but it's cool. It's a great show. You should watch it. It'll teach you, a lot about it. There's a lot of life lessons in the show. And I definitely think if you're not familiar with it, you should go watch it because it's one of the biggest phenomenons ever to hit the world. They make an absurd amount of money. Apparently, Pokemon Go, things like this is a $1 billion industry. So definitely check it out. So now we know what DevOps is. Now we know what Pokemon is. most people think the advent of DevOps happened in the early to mid 2000s. There's actually two people that they credit to be the arbiters of DevOps, the people who created it. I am arguing that that's not true. That DevOps actually taught me all the things that I needed to know, which means anyone else who watched it, anyone else who was a part of the phenomenon, watching the shows, playing the games, you learned all the things that you needed to know to be a DevOps engineer in today's market. So I should probably move all that stuff. But cool. So does anybody know the first lines of the theme song? The first thing that comes on, you drop the beat. I want to be the very best, like no one ever was. Right? The best power ballad of all time. That is how Pokemon starts, and that is exactly what DevOps is intended to be. It's the cultural change to take an organization and to operate it in a way where you can do things iteratively, where you can fail fast, and you can turn that organization into the best that it can be. That means a lot of different levels, but that is the goal of every organization who's practicing DevOps, is to change the way you do things to be the best that you can be. Actually, I don't think this is my latest. This is not my latest. Sorry about that. Let's see if we can find the latest one. But I will keep going. So, while I'm looking for this, what's the first thing Ash does in the show? Or if you didn't watch the show, you played the game, what's the first thing you did when you played the game? What's the first task that you had? Get a Pokemon. Right, you gotta choose a Pokemon. That's the first important. That's the first important task. We just changed the internet. That's the first important lesson that you learn. One, DevOps is big on tooling. DevOps is actually the culture of DevOps is actually enabled because of tooling. So advents like the cloud, being able to rent infrastructure, being able to rent compute space, being able to rent storage, rent RAM, being able to codify or to put in code physical web infrastructure is what has allowed this. This tooling is very important. But in that, the tooling is vast, and that is one of the reasons why DevOps is perceived to be so difficult to get into. Because anyone who's trying to look into DevOps has Googled it, tried to learn what tools you need to know, and they've come across hundreds. They've come across a list of all these tools you should learn. You should learn Jenkins. You should learn Circle CI. You should learn Linux. You should learn AWS. And AWS has 1,000 services. You should learn Node.js, but also you should learn Python, and also you should learn Go, because now that's what people are using today. And oh no, AWS is not really the thing. Everyone's looking at Azure because AWS is too convoluted. So it can be very confusing. And this is what Pokemon taught us when they first introduced you to three choices. And this is kind of how DevOps started. But they introduced you to the first three choices with different attributes, with different powers, different strengths and weaknesses. So you start the game or the show, you had the option between choosing a fire type Pokemon. You know what Pokemon it was? Charmander. Debatable, and we're talking about why, and we're talking about why you should use why when you're figuring out which Pokemon to choose, you were also doing the static analysis and the gap analysis of choosing your first DevOps tool, and teach you how to analyze which tool to use for the job. So there was also a water type Pokemon. You know what that was? Squirtle. And there was the last one. Of what type? Grass. Cool. So we got this. We've already been introduced to this variety of types. These different tools to do the same job. They all fight. They all are there to give you the end goal. I want to be a Pokemon master. I want to go do I want to go to the Elite Four. I want to win. I want to be Pokemon master. I want to be the best one out here. But we got three different Pokemon to start. Now, you said Charmander, fire type Pokemon, right? Best option in the game.
Yep.
Tell me why. So I like what you said. Why you work harder to get?
The first gym leader is mainly weakness. The second gym leader is water side.
Excellent.
So we're just compounding.
Perfect. Yeah, right. So like everyone who was invested in Pokemon the same way I was knows that when you chose Charmander first, because everyone did when they first got the game, you chose this Pokemon purely because you liked it. You like fire, and he's like a little lizard. You're like, cool. This Pokemon looks cool to me. But you didn't. But before you played it for the first time, you did no. You had nothing else to analyze off of. And you chose this Pokemon like most people did because it was a cool Pokemon, and you went through and found it very difficult to get the first two bosses, right? Cool. This right there, you've learned how to analyze tools. Remember when we went over the definition of why is that super useful? I want to go back to the definition of
You want
you just connect me to the internet. That's why I wasn't updated. But when you chose Charmander, that's all you knew. But you didn't know that the first boss you were going to go up against is of rock type. And then the definition we saw here about DevOps was that it's a cultural shift where you take where the change is based on the experience of your engineers. That's kind of what matters most. And then so after you have that experience, you know going into the game, as much as I like Charmander, as much as I chose Charmander the first time and I struggled through, I knew that when I played the game the second time that I should probably choose Squirtle or Bulbasaur. Bulbasaur will win me both the first two real easy, but we knew there was some trade-off there. We knew that grass type had its weakness against fire, and as I got farther, like those are extreme weaknesses, not quite as much as some of the others. So that was your first foray, and this goes to engineering period. When you got to analyze the tool set, especially in an industry where the tools are so cool, where there's so many tools, we learned how to do that analysis, and we learned that there is a right tool, or there's a sensible tool for the job, and that's one of the biggest jobs you're gonna do as DevOps engineers. Is tool is important. DevOps doesn't exist without tools, even though it's a cultural movement, but selecting the right one.
How much you govern by what you know?
Say it again.
How much you govern by what you know?
How much you govern by what you know? Almost completely. I think so. I actually had a pretty interesting conversation at DevOps Days Baltimore. There are these things called open space groups where you kind of sit down and you talk about different things. People talk about how do you get into DevOps? Like how would you tell someone to get into DevOps? And we kind of got to the point that we determined there might not be a JV team per se for DevOps because it's based off of these experiences. You can learn a lot, but it means nothing. But you can.
That's a very comforting answer.
So understandable. I would argue that you wouldn't even want to get put in a position where.
No, I totally feel you on that.
Yep. And so I think you can get. I think you can get these experiences. I don't think you need to get these experiences through a job. I think that there are a lot of things you can do to practice these things and to understand these concepts. But I do think good DevOps comes from a place of experience. I think the best engineers that I know, the DevOps engineers that I know, are very experienced. And it's not experienced in the amount of time. You can work somewhere doing the same thing for years and be great at your job and not be a good DevOps engineer or engineer period because you haven't had those varied experiences. You haven't been in enough situations to show you how to handle scaling a service to meet the demand of a million users overnight, or things like that. And so that's where a lot of this comes down. So back in here. But yeah, it is an experience heavy game for sure. Let's see if this is the updated stuff. All right, well, so cool. Second thing that we all learned from Pokemon is very important in DevOps. And this is a DevOps usually operates in a Kanban or Agile Scrum fashion. But we learned a lot about something called iteration. And so I showed you that feedback loop earlier. I click on this now. And I showed you the feedback loop here. And it shows us doing the same process over and over again. So let's talk about why that process is important. So most people, things used to be done in a what's called waterfall fashion. And that's basically like, hey, I need a website built. I need this feature. I need the whole website is the product, and you and your team are gonna go develop this thing. We're gonna build it to completion, and then we're gonna release. The problem with that is you never will finish, or it'll take a very long time to finish. And by the time you finish, it's time to move on to the next iteration of the site. What Agile Scrum kind of brought in is doing bite-sized pieces of things, picking something called an MVP, choosing something called an MVP, working towards that. MVP stands for minimum viable product. So this is just what's the minimum amount of things that we need for this product to be useful to our users. That's what the whole goal of all this is to deliver value to your users. And so the goal is to work towards that, and then to reassess, to say, hey, like we put this out, we built this tool to take in your email and to put you on a newsletter so that we can get better website engagement. And we'll put that out, and we'll take in the metrics, we'll analyze it, we will see if it's doing what we intended, but do what we intended, and then we'll change it. We'll make decisions on it, and we will make it better. There's no reason we'll pivot. So instead of going from, we start here at 0, and then we take our product and we end up all the way to here. This is the goal up here, and building it, and then only releasing once we get to here. Now what you can do is you can take the start of your product, you can aim for here. And then you can figure out if you are on track to meet your goal. And it allows your goal to change. So your goal may be that you want to not create this type of application. We may want to create a form that does some AI and analyzes the things that the person put in to give them better recommendations on things that we're going to put in the newsletter. But when you're building towards this goal and you're building to release, like you don't have any options in there to change path, pivot, to go a different way. And that's what this iterative nature of things does. So and how this relates also back to Pokemon, the way that Pokemon talks to this is after you go to that first gym leader and you lose with your fire type Pokemon and you only picked up 1 or 2 Pokemon along the way, what do you do next?
Pick up a grass Pokemon.
You cry and you go back out and you pick up a Pokemon that works for you and your team. You got your team of Pokemon here. And I attribute the team of Pokemon that you have. Anybody know how many Pokemon you can have on your team in the game?
3,
6 at a time. You got 6 different slots for Pokemon. That's all you got. DevOps is very similar to that. Where there are classes, there are really classes of tools. The first tool at the start would probably be your programming language of choice. So you got to choose one. You might choose that based on, I want to use something that's flexible enough and easy enough for anybody to learn, readable enough to anybody to hop into. You might choose one that maybe less readable, but very difficult. It's very fast, a lot harder to write. You might choose one that's old school, because maybe you have people in your organization that's all that they know, and you don't want to hire anybody else. So a lot of options there. So you got to fill that Pokemon slot. You got to fill your programming language slot. Then you got to fill your source control or version control slot here. You got to fill that tool slot. So your people are writing code, and you need a way to manage that. Everyone can't have the code saved in their computer. Doesn't really make any sense. So now you're probably going to use Git. I doubt you're going to use SVN Subversion. These are older technologies. But you're going to choose one of these. You're going to choose GitHub, or you're going to choose Bitbucket, or you're going to choose GitLab as your repository for many reasons. Because maybe it's based off of the next tool that you choose. Maybe you want a CI/CD tool. So maybe you're moving on to that third slide, and you want Jenkins or Circle CI. And you can see here how I'm throwing out tons of tools. How many original Pokemon are there? 151. All with their own attributes, all with their own strengths, all with their own weaknesses. And all you did constantly was look at your Pokedex. You would catch one, you'd be like, do I want this? Is this going to work for my team? Is this going to be good? That static, you've been doing it your whole life. Well, people who play Pokemon. Anyone who's not playing Pokemon, you should probably play with Game Boy. Maybe Pokemon Go might do it a little bit for you. You should definitely go back and watch the original season. It'll teach you a lot about your life. You'll cry once or twice, but it's all good.
Really?
But so after you look at that, you're like, all right, cool. Now what are we gonna do with that? We gotta put this somewhere. Are we doing our 4th slot? Do I want to host this on site? Do I want to put this in the cloud? Do I want to use AWS? Do I want to use Azure? Do I want to use Google Cloud Platform? I don't know. Then you might want to move into, you might need an artifactory. You may need all these different types of tools. You will need all these different types of tools to achieve. You do need these tools to achieve that iterative workflow, that feedback
What is
workflow.
artifact?
So cool. Artifactory is it's a repository. So it's a bucket for the artifacts
System
that your build tool makes. So when you write an application, let's say we're writing a JavaScript, a Node application, when we run a build on this, we'll send this through our continuous integration pipeline. We'll have a server. Basically, that's a service that will run some tests against it. You write some automated tests to test the functionality of your site, to test the functionality of your code beforehand. It does it. It goes through, tests all these things. It deploys. There has to be an output of that. The output of that is usually things like images. Like on these pages, there are these images, and there may be some PDF that you have, and then there's actually application code. So there might be some kind of file, file that's needed to run, that you need to run your application. Those are artifacts. Artifacts are the build. Those are. It's not always necessary, but it's a place that houses and stores the outputs of your build process.
Oh, so like if you were using a compiled language like the DLL.
Say it one more time.
If you were using a compiled language like DLL.
Yep. If you're using a compiled language, it could simply be your executable that's put out from the compiled language. It can be one of a lot of things. A lot of builds have all kinds of things they put out that people need. So like.
I thought you were saying like test results. Like
So test results, usually you wouldn't consider those artifacts. You can have output from the test results. Those wouldn't go in what is your artifactory typically. But this is why the tooling gets so complicated. This is why tooling gets so tough. This is why you need to be constantly taking a look at your Pokedex and updating your knowledge about things that are coming out. You need to know that you have access to those 151 tools to start, but next week now there's 25 new tools that I got to check out. That might be good. That might be good for my organization, but may not be. Again, right tool for the job. I don't think there's a wrong answer. You can win the entire. You can beat the game with the same type of Pokemon, and you have 6 of the same type of Pokemon. You could if you get strong enough with them, but it's just gonna be a lot harder. And those lessons absolutely apply here. The next one, a very interesting one, is one of the biggest problems with both DevOps and engineering here is over engineering. So we talk about the right tool for the job, which is important. But what you want to be careful of, because of all the tools, is over engineering. Who's familiar with containers? Those things like Docker, is anyone familiar with Docker? All right, so has anyone heard of Kubernetes? Cool. So Kubernetes, if anyone's interested in DevOps, first thing you should do, like the first thing you should do, is go learn about containerization, go learn about Docker. If you want to make money, if you want to absolutely do a job, go learn about Kubernetes, understand Kubernetes, get to know Kubernetes. Docker is just it's a way to package up your apps. It's a way to easily package up and run applications. That's all it is. We don't need to get deeper than that. Kubernetes is a way to deploy and manage lots of Docker containers. So bigger organizations, organization like Google might be running hundreds of thousands of Docker containers at any given time. Like honestly, hundreds of thousands. And you need a way to manage that. So Kubernetes is something called an orchestration platform. And so you can think about like the symphony orchestra. You can think about a conductor like in a band, symphony orchestra, and you got your flutes over here. So your flutes will be one set of containers, and there'll be a bunch of them over here, and they'll be telling those things what to do, and your tubas over here, and your woodwinds, and all that stuff, and your percussion. That's what Kubernetes does. That's not important. That's just a little bit of extra sauce there. But where did I start with this?
Say where you
Something
going with
about
it?
containerization.
Overworking.
Oh yeah. Perfect, bro. Over engineering. But so you can see how if you wanted to, if you started a business and you had a WordPress site and you had 20 users hitting your site a day, you can see how something like Kubernetes might be like a lot of work, and there's a cost. There's a cost to that.
Pause real quick. Is anybody packing a big pack of nuts to the next? Okay. It's on.
We're looking at.
Cool. So yeah, so there's a cost to that, and there's a cost to all these trade-offs. But there's actually a lot of it takes a lot to be able to provision Kubernetes instances and to manage them. But it's easy to fall into the trap of using tools that you're not ready for, that your organization doesn't need. So DevOps is about finding those trade-offs as well, so that your team can work fast. So in Pokemon, what happens if you end up with a Pokemon, or you train a Pokemon to a level higher than you can control? They don't listen to you. And this is a very, very common thing in the DevOps community. People taking on tools that they don't need. That's really too much over-engineered for their product. And what happens is the time spent maintaining, the time spent troubleshooting, the time spent wrangling these technologies becomes extremely detrimental. And it's one of the reasons why a lot of the companies that you work at right now might be trying to practice DevOps and are pulling back away from it because they do things like that, and they get some executives sat through a briefing of this tool that they should use, and so they said, that sounds great, it's easy for us to deploy this container, but you don't even need containers, or you don't run them, you have one container. And you get into situations where things are over-engineered, and it honestly, it is detrimental to your workflow. So if you're getting into DevOps and you're trying to figure out how to attack these things, stick with the tools that work. Stick with the ones that you know. Stick with the ones that are at the very least technically feasible. That's really the very issue. It should be technical feasibility first. Does this tool solve my problem? Next, I would probably hit cost, and then the last one would probably be the ease of either onboarding or teaching people this new platform. Along with that, does anyone know what happens if there's a cool trick in the game in Pokemon Red and Blue version? If most people did this, you gotta do it later in the game. You're about to go to what's called was it the Final Four or the Elite Four? You're about to go to the Elite Four. The last four big battles of the game. These guys, people have the strongest Pokemon. There's a trick that you can do on an island. Missing no. So there's a trick put into the game. And so what you can do is Pokemon that you didn't train. You spend the game. A lot of people when they're younger heavily invest into their starting Pokemon, or the first two Pokemon, and they'll end up with, you got 6 Pokemon slots, but you might get halfway through the game, or almost all the way through the game, and you might have your Pokemon can be trained as you fight. They gain levels, they learn new moves, and you can raise them from level 1 to 100. 100 being the top level. What happens is, as you fight, you end up using the same Pokemon, because the Pokemon you start out with, those are, like, when you get to the big game, those Pokemon are level 30, level 40, and you're catching new Pokemon at level 16 and 17, people tend not to use those Pokemon anymore. People don't put the time and the energy to building up those weak spots of their team, and a lot of people get to the end of the game, and they have a team of 3 that are level 70, 80, 90, and then their 3 remaining Pokemon are level 28, level 16, level 5. Like, this is a very common thing. This is something that happens in DevOps constantly. Focusing your energy on the tools that you're good at, and not actually using this feedback loop to fill in one of these blocks. So you might have a great tool. You may be great at deploying. That might be the thing. Like, this might be your customer might love you because when it's time to deploy, we deploy in our application in 5 minutes. And that's unheard of. Like 45 minutes, we've got our new features out there, how much we use. But you might have terrible monitoring. you might get that application out there and not realize that you got memory leaks everywhere, or that tons of people are hitting this and your database is about to hit critical mass and nobody's going to leave your site. Or you may have great monitoring as well, and you may have great planning, or you might have you may have chosen a crappy frameworks, crappy coding language to use for this intended use. And what happens is a lot of people tend to save themselves by again just bolstering the places that they're good at and they know. DevOps is difficult because you've got to be a part of all of these different things. You got to challenge yourself to invest your time in those things. Like the thing I'm worst at right now is probably I'm not good at writing tests or being a good tester. That's me really leaving an open slot on my 6-slot Pokemon team. You know, I'm going into the Elite Four. I'm a technical lead for a government organization. You know, I'm helping run their entire web infrastructure, and I'm going in to fight the Elite Four basically with an efficiency. Luckily, I can lean on my team. We have testers on our team, and because we broke down those silos. Remember, I had talked about the silo between development and operations. There's also silos in between the other teams, testers, UX, UI, and security is probably the biggest one in regards to DevOps right now. The DevSecOps is almost bigger than DevOps alone right now.
Well, that's where my questions are going to be once you get ready to talk.
Cool. Yeah. I mean, it's like that's probably the biggest thing right now. And how do you incorporate all of these things basically into this pipeline? How do you get all of the things on a team? How do you get all those things into this 6-man slot? You only got 6 slots. How do you get something that covers all of these things into this 6-person slot? And again, Pokemon, that is what we did. That's what you did growing up. You weighed those options. You figured out how, when I go into fight these last people, they all have different types of Pokemon. They all have different weaknesses. How can I bolster my team? How can I put myself in a position to be great? Great when you do this. Also, the missing those what you can do is there's a cool island in the game. You get over there, you could ride up and down the island until you ran into this bug of a Pokemon. It wasn't a real Pokemon, it was called Missing No. And what happened is you could, I think if you caught it, or I think you weren't supposed to kill it. You would catch it, and it would give you something called rare candies. So rare candies were a tool in the game where you could level up your Pokemon without having to get the experience of them fighting. So it was rare candy trick. You would do this. You would take your level 16 Pokemon and you would do this trick until you had enough rare candies to raise them up to level 100 or 99 or whatever the top was. But does anyone know what the difference between a Pokemon raised with rare candies and a Pokemon raised by experience was? Yeah. So 2 level 100 Pokemon are not created equally when one is used to use when you essentially cheated to get there. And this goes back to the tooling. This goes back to over engineering. When you take a tool, when you try to just use a tool to solve a problem that you have in this workflow, in this pipeline, it can be detrimental than if you took the time to really address it. And that's one of the difficulties right now because DevOps is tools enabled. Like DevOps wouldn't be a thing without the tools. It really wouldn't. But at the same time, leaning on these tools can really hurt your flow. It can really hurt a team. It can add unnecessary complicated steps. It can add another weak point of failure to your team. I've worked on teams where we had 3 or 4 levels of tools that were not necessary to get tools in production, where they were sold this cool thing that did something that they thought would be great. Executives were told that, hey, if you run this thing, you can be confident that your stuff will never break, and they bought it. Or DevOps engineers went to you go out to meetups, you go out to conferences, and there will be vendors there, all trying to get you to use their tool. But be wary, just like in the game, knowing when you shouldn't, raise all your Pokemon with rare candies, because I'm gonna have some weak ass Pokemon ready for the end. It's not really gonna help me win the game. It's not gonna help me get to the end state that I'm trying to get to. It's not gonna help me be the very best. Knowing how to avoid those things is important. Other people, but this is probably the last one just for time's sake. State management. This is a big thing in DevOps. And not state management as if you were developing an application and figuring out, what the user is doing at a time. We're talking about the state infrastructure of the state application. One of the biggest tooling benefits of DevOps is that now, we talked about earlier, is that now you can codify and you put into code your web infrastructure. I can take a file, I can write a few lines in it, and I can send that file off to AWS. And I can say, hey, I want a server with this much CPU. I want that server to also have 32 gigs of RAM. I want it to have 500 gigabytes of storage, SSD storage, and then I want it to also connect to this network and have these subnets. And I also want to have an S3 bucket. And I also want to have this database of this size with this much IOPS. And so now you can take code and you can write out a shopping list essentially, and you can hand it to a cloud provider, and they will give you what you ask for. You pay for it. You pay for every little bit of it, but they'll give it to you. So it's easy and it's repeatable. So a cool thing in the game. How do you when you're traveling around each city, and the game is laid out, really well. Each city has a place. It has two places, but each city has one specific place that is there to save you, and there is to be a point of reference, and to be a point of repeatability. Do we know what that place is? Pokemon Center. Boom. What can you do at the Pokemon Center? You can heal.
Get your Pokemon from the computer.
You can trade in your tools. That's about it. That's all cool stuff. You can also trade from the Pokemon Center. I'm pretty sure it's Pokemon Mart. I don't know. I think you get the little cable and you trade with your friends. That's cool.
Just
Alright. Cool, yeah. So Pokemon Center. So what they taught you in the game is before you went to go fight the boss of the town with the gym leader or the final four, what did you do? You go to the Pokemon Center, you heal, you save. And when you heal, I think it saves. But you heal all your Pokemon. And because when you die, where do you end up back at? You end up back at the Pokemon Center, right? Cool. All that was teaching us is state management and reusability and almost a little bit of something called immutability. So this is reach.
That's good, yeah.
Okay. So what it's doing is you got your Pokemon. Now my Pokemon all die, the game's not over. You wait, you go to sleep, you wake up at the Pokemon Center. All your Pokemon are healed. That is exactly the world we're in today. This is like that almost to a T is why we have DevOps. That shopping list that I gave you, that shopping list, when you have issues, if you build your things right, when you're running through your DevOps workflow and you're building things, what we've learned is that you don't need to repair. You don't need to repair the things that you have. You don't need to treat your Pokemon. You don't need to treat your infrastructure. You don't need to treat your tools like pets. So your pet, your dog, breaks his leg, you take it to the vet. You pay to get surgery. You get a cast. You bring that dog back to 100%. That's how the world it still exists to this day. That's how it used to exist. That's the job generally of the systems administrator is to take care of this catalog. The company buys some servers, buys some hardware, takes it, installs some stuff on it, keeps it updated. As things go on, you log into it, you install things on it, you update things, make sure it's still running, you keep it going. DevOps, you want to treat things. You generally want to treat things like cattle. This is a little morbid, but this is how they've explained it. This is how people think about it, and it makes sense. On a farm, sick cows, like you don't nurse them back to health, like they gotta go. You kill them, you replace them. And this is what things like deployed codified with global infrastructure have taught us in terms of DevOps is that we can go into battle with what we think is great, what we have, with the safety of being able to try this again if we lose. Not only is that part of so immutability is something not persisting. It doesn't persist. So there's no safe data, there's no safe state. It is something that you can throw away. And that's essentially what your Pokemon team was. That's what they were teaching you is that, hey, like I know these things are dear to you, but you fight this battle, you die, we'll throw it away, we'll start over. And that is a concept that we use near and dear every time. All of our infrastructure right now. So I help run the small business administration's infrastructure. We could have a catastrophic failure in US East 1. So this is in Northern Virginia. There's some data centers, there's some servers that Amazon hosts. Those things could all go down right now. Somebody can blow them up, all good. Because of what we've learned and because of the way we decided to engineer things, because of this concept, we can take the code that we have sitting in GitHub and we can change the target. Instead of building something out in Virginia, we can say, put this in Oregon because Virginia's gone. And we can send the shopping list back out to Amazon, and we can be all the way healthy again. We can die, and we can end up back at the Pokemon Center healthy again. I mean, we can do this in a limited number of times. And this is probably the most important concept of DevOps in that nothing needs to be permanent anymore, which is a pretty wild concept. But that was a good slide to what I was going to say, but now I'm not going to say it. But what it allows you to do is to do that iterative thing that we were talking about before. If you don't have something that sits around, you can move faster. You know, as you guys develop, your applications, you can, instead of having to worry about how do I update this thing to make this thing work with what I've got. Instead, I'm gonna tear it down and throw it away. I'm gonna build this new thing, and then I'm gonna deploy this new thing as is. This whole new thing is my application. It's not just the application code. This is not separate from the servers. Our application code actually lives with our infrastructure code. It all gets deployed together. So when we go to deploy a new update to our application, depending on the update, sometimes what happens is it spins down all of that hardware. So imagine we setting some servers on fire, throwing them off in the corner, somebody bringing in some new ones, hooking them back up, installing everything on them, and getting back up and running. This stuff happens in a matter of minutes. But again, that's the tooling that takes effect. But that concept, we've learned it. Like you've done it before. You've seen it before. You've seen Ash get his Pokemon whooped and take him to the Pokemon Center. Except when Charmander almost died. That was pretty sad. He went out. He was not fully beautiful, but the rest of them were. But yeah, that's the last piece. I'm gonna keep it there just to keep it short because I have like 30 other ones to talk about. But yeah, if you want to learn more about DevOps, I highly encourage you to go watch the first season of Pokemon. I highly encourage you to go grab.
The first season.
No, yeah, I highly encourage you to go. Huh?
Where can you watch it?
I was.
Oh.
I mean, nah, you should watch Pokemon just because it's a good, wholesome show. You should be able to experience the greatness that we all experience. But no, go get yourselves a copy of red and blue version. You can get one of the newer ones. All the games teach you the same, and they all kind of follow the same paradigm. But look around you, start seeing the things that you're doing, and when you get on your jobs or when you're searching any field of engineering, really, because honestly, a lot of this applies to a lot of fields of engineering. Like, take a look at the stuff that you really know, that you've learned from different facets, like Pokemon. Maybe you watch, there's a lot of stuff. I was going to do this talk about Attack on Titan instead. There's a lot you can learn from that, but you can learn from that as well. But take a look at that stuff and take a look at the concepts that you need to apply to do these jobs. And you'll realize that you know this stuff. Like, it's not magic. It really isn't magic. You've done this stuff before, but because people hide it in code and all these fancy words, it seems a little more complicated than it is. Ain't complicated. But that's my talk. Again, my name is Aaron. I'm passionate about DevOps. If you want to know more about DevOps, I'd love to talk to you. And that's all I got.
Thank you.
Anyone have any questions?
So I have a
Anyone in
question.
DevOps right now?
I have a question.
Go ahead.
What have you seen in terms of security being practiced in this? Like, do you see, aside from maybe running some security tests, like, do you see documentation being created as part of this? Like, how does risk incorporate?
Security and risk are a very interesting one. So what I've seen lately is, and we're guilty of this on our project, is circumvent. If you don't have a DevSecOps team or security dedicated security person, nowadays it's fairly simple to because of how many services there are that you don't manage anymore because there's so many things as a service. I'm sure you guys yeah. You hand that job off to someone else. So like we actually don't have any servers anymore. We are running all of our stuff through lambdas, so serverless functions, like Fargate containers, and we still have some containers, but you can't really scan them, and they're ephemeral. So
You mean like the Azure functions?
yep, like Azure Functions. So just like Azure Functions, I think Google's called Functions as well. But to get around the security concern, we have containers that run. They want to scan them. We're like,
You
why?
cycle them so they can.
We cycle.
Wow.
We cycle.
That's
Containers don't
almost a
last.
dirty trick.
Containers don't last for more than 4 hours. So
Wow.
we cycle them out to avoid that. But there are a lot of tools that have been made for like testing compliance. So you might want to test. I think Chef has one called. Chef has one for compliance.
Yeah. So, full disclosure here, I'm trying to have a product that reads documentation. We're trying to get into this SecOps space doing exactly that. And so, figuring out how people actually go about implementing it, or trying to give them a way to implement it, is kind of
Yeah, it's the Wild West right now. I'm doing those. Like everything's moving.
That's why I'm trying to look. My
Yeah.
product does it for you right here, right? Implement all your security. So
100%. I love talking about that, but like when I tell you, you can.
yeah, I mean, what you just said that, like, I mean, I can certainly see people doing it. I might even see myself being guilty of cycling things so you can explain them. But I don't know if that really.
That doesn't mean
like,
you're
should be-
safe.
yeah, I mean, that's.
That could mean you're just spinning up thousands of vulnerable containers.
Exactly, that's what I'm saying.
over and
It's just like making it so that people aren't finding what's your problem. And that's actually a valid thing to do, right? Because being on and off quickly, that kind of minimizes your this area.
It minimizes it, but there are reasons why. I mean, security is always going to be the biggest thing. I mean, there's reasons why large corporations are still being hacked. They're always being hacked. People are all like, this is a living organism.
Absolutely.
Like you make a change to block one thing, you're gonna open up a hole somewhere else. Like it's ever living. I mean, security is the biggest thing being pushed into the DevOps workflow. Like more than UX, more than testing.
So documentation is not a thing.
Documentation is 1,000% a thing.
So where does your documentation get created?
In the infinity loop, some of it gets created some of it gets created as you code. So our devs are required to do a fair amount of documentation. Some of it gets created, things like documentation for our APIs and things gets automatically created using tools like Swagger. Besides that, our applications are fairly straightforward. So there isn't a ton of application documentation that needs to live outside of the READMEs for inside GitHub.
Well, I know you guys have to get accredited. Like if you're doing federal government software, there's an accreditation.
There is, which is easy to do if you are using FedRAMP compliant software. You'll get your ATO for it if you're using FedRAMP certified stuff. So like we're basically just using, and like a lot of AWS services are. But
Well, I mean, I use that for my own way of getting certification because I run on Azure as well.
yeah, no, 100%. But security is also one of like that's something I'm working on right now as to fill in those gaps to add that Pokemon, like that strong security Pokemon to my team. Like that's one of the ones like I'm great at the cloud. I've got a pretty solid like development status here. CI/CD, I'm great at that. Testing is definitely one that I'm like learning a lot about. The securities a big one that I'm learning a lot. That's what people need nowadays, and how to address those things. And also, you can't always work in an environment where you have these servers that you cycle. Like every environment's not the same, and that's why it's so important to learn how to analyze tools and analyze what you can use. Because I need to work for a company that will work on a project where we can't use containers at all, because for any number of reasons, where we have to have servers. And maybe I need to use instead some configuration management software like Chef or Puppet or Ansible to do some runtime configuration of the servers. And that's when security is a huge deal. Like when you have those, when you no longer have cattle and you're back to pets again, security is like number
Well,
one.
I've worked in the federal government for my entire career. I've never worked on a project that we actually use containers.
Exactly.
I mean, shoot, all the ones I'm bidding on now, we're not using containers, so.
Real quickly, so, what's the best advice you would give someone that is interested in becoming a DevOps engineer? At least, what are some of the competency skills that you need to acquire, to at least get into the role in the
This is perfect. I'm glad I have this up here. DevOps roadmap.
students and admins that kind of thing. And I know that DevOps is
I'll just put it over here.
So really wish for that thinking. Me with HR systems, I'm actually on the right side of the DevOps. Yeah. Talk about that.
Yeah. So one of the things that makes DevOps so lucrative. So DevOps, I'm not gonna sugarcoat it. DevOps is very lucrative right now, probably for the foreseeable future. You go look at the salaries, like it's lucrative. But again, it's because of that. You are paying for that experience. And that's why it's a little tougher for people to get into this. You need to know the full scope of what goes on in the application. You can't just write the app code. You need to know how it's configured, how you get that deployed, how you do the builds, how you monitor it. You kind of got to know the full life cycle of an application. But this is a really good DevOps roadmap that was created to kind of teach you the tools. Now, you won't need every single one of these, but I think there are nine categories within our board. So learn a little bit about programming languages. You do not need to be a software developer to be a DevOps engineer. The more you know, the better you can be, the more automation you can implement, things like that. But definitely learn how to code, even if it's just Bash. Like pick a programming language. I would probably go with Bash first. If you've never touched any programming language or like you don't have much Linux experience, just to like help you get that logic, because we do a lot with Bash and systems. But probably Python is probably my go-to to teach you. Like, if you're looking for one programming language to pick, it's probably the most versatile, especially in the DevOps space. Pick a programming language. They've got some options up here for you. Different operating system concepts. So this is like the crux. This is like what systems administrators do. This is the sysadmin. The first part is the development piece of a programming language. This one's the ops piece. So learning about process management and IO management and different types of virtualizations. We talked about containers, but there's also traditional virtualization, which is like VirtualBox, virtual machine, and file systems and memory and storage, and just learning how like really operating systems work and how you can kind of manage them. Third one, learn about managing servers. So this is a little bit more stick with Linux. It says Windows. There's something wrong with Windows Server. Something like 93% of the internet runs on Linux servers. A lot of people don't know that, but the internet runs on Linux. And so you're anyone who's using a Mac, which is Unix based, it'll allow you to learn a lot of stuff about Linux and be able to practice stuff without having to actually hop into a server. You able to learn this concept. Windows is actually shipping this summer with a full Linux kernel inside of it. It's also got something called Windows Subsystem for Linux, which you can practice with. Plenty of ways you can get that information. I can give you guys some information on how to get the server management. Networking and security, definitely an important one. You don't need to be a network engineer. You don't need to like dive crazy deep, but you do need to understand. You need to understand how the internet works. You need to understand how requests are made between servers and hardware. Like you need to understand those things. You got the OSI model, maybe, sure, we didn't know. But the cloud, the internet, is just one giant network. It's just a network of computers. Like, that's all it is. Just like a network of people, it's just interconnected pieces of hardware. That's all the internet is, nothing special. And they're all just talking to each other. That's all it is. So understanding how that works a little bit helps. What is and how to set up like a reverse proxy, caching server, and web servers. So this is really important. Understanding web servers. This is probably the easiest one to learn. The ones in yellow are the ones you should probably pick. Apache or Nginx. I go for Nginx, but either one of those is good. IIS up here is the Windows web server, but understanding how to serve content off of a computer, off of a server, is all a web server does. But just learning how to set that up and learning some of these terms helps. Infrastructure as code, we talked about that. That immutability, that being able to provide Amazon with your shopping list of web infrastructure. That's what infrastructure as code is. And there are a few tools for that. And there's also three pieces of this. And this number 6 is the most important.
Can you read it out?
Yeah, I'll read it out in a second. Okay, I think it's tied with the cloud. So the cloud is number 9 over here. Number 6 is probably what you can learn to get a job the quickest. So infrastructure as code, 3 pieces. We talk about containers. Under here, containers, there's Docker, Rocket, and LXC. Don't learn Rocket or LXC. Docker's all you need to pay attention to, because containers are codified also in a configuration file. You write a configuration file, it spits out a container image for you, and you can deploy your application based on that. Configuration management. So the first one would be virtualization, really, not just containers. Configuration management is a big one. So this is runtime configuration. So this is basically you declaring the state of your server. So the same way you would pass AWS some stuff to get your physical infrastructure. Once they give you a server, you still got to install stuff on it. Like, you still got to do stuff with it. That's what configuration management is. You declare a state in some files. So you write a bunch of files and say, all right, I want this application installed, and I want to copy this file to the server with this information in it, and I want these users to be on the server. Configuration management is how you do that, and you run that on servers and it sets it all up for you, so that you don't have to really worry about that. And then infrastructure provisioning is what I was talking about, like specifically when you pass AWS or Azure your information, and they give you your physical hardware, or like the actual underlying infrastructure. The major tool for that is Terraform. Learn Terraform. Like, if you want to be a Devops, learn Terraform. Learn Docker, learn Terraform. CloudFormation is AWS specific. I probably stay away from that. Terraform is cloud agnostic, works for all the cloud providers. But yeah, this number 6, infrastructure as code, is learn about it, spend some time practicing it. It's pretty decent practice. All the tools are open source, and you can just kind of hop in and do it yourself.
And we also have an infrastructure channel, which is plugged into that. If you have any questions,
So CI/CD, so this is continuous integration and continuous delivery. There's actually another CD on here, but usually this is CI/CD is the buzzword, but it's really CI/CD, continuous integration, continuous delivery, continuous deployment. All this is this allows your team of developers to write code and to safely get it integrated into the code base without having to do any work. It does this automatically, and that's what continuous integration is. So basically, a developer will push code, the continuous integration tool will see that, will check your repositories, your GitHub, whatever. It would run some tests that you wrote against it. You set it up how you want, so it may check. It may run the linter and check to make sure the style of your code is right. And then it may run some integration, some unit tests against your code to check your functions, make sure your functions are right. And then it may run some integration tests and things like that. But it'll run your test suite, and then it will say everything's good, let you know if everything's good, and then it'll leave the code in a state that's ready to go. So that's the CI. The CD is continuous delivery. So CD is just the deliverable of that. It runs all that stuff. CD would be delivering you a packaged up version of your application or those site assets that I was talking about, giving you your images and things like that. It's the output of the CI process. And the second CD is deployment. So you can automatically deploy these things to a server. So you can have a process where someone pushes code, it runs through this pipeline, it spits out some assets, and those assets automatically get pushed out into a place where the world can consume it. They'll automatically push it out to a server, and that's what deployment is. This is a close second to number 6 and number 9, to the cloud and to infrastructure as code. CI/CD is right underneath it. But like these are the things people want when they say they're a Devops engineer. They want these things. And so understanding that. Number 8, how to monitor software infrastructure is important, but this is definitely the easiest of them. A lot of tools for this. Stay away from Nagios. Your company will probably have a tool that they're willing to pay for monitoring. It'll have good documentation on how you set it up. So monitoring is not it's not that hard to figure out. It is an art to figure out what you need to monitor. That's what comes with experience. But understanding monitoring and log management is not too difficult. I'll probably put it pretty low on the list, to be honest. Like if you're trying to get through this stuff fast. And then cloud providers. So here they have AWS as the top one. AWS is by far the biggest cloud provider, has the biggest market share. It does not make the most revenue, which is very interesting. They have a substantial market share over everyone else. Like on the graph, like it's a really cool if you see the graph. AWS is like way up here. Azure is by far in second. Like they're far behind AWS, but they're way ahead of everyone else. Then it's like AWS all over here, Azure right here, then like Google Cloud Platform down here, and then like 60 other little cloud providers like Oracle and Pivotal and like there's a lot of people in the game. There's a lot of money in the game. Microsoft actually makes the most revenue. Less market share, they actually make the most revenue. If you don't have a lot of experience, I'd actually recommend that you go into Azure instead of AWS because it's a relatively niche market. It's very difficult to find Azure engineers.
Is that true?
Huh?
I didn't know that was true.
It's absolutely true, and people are paying a lot for Azure engineers because they're hard to find. And especially in this area, especially if you're close to DC, a lot of government is like, we need to use Azure, use heavily for Microsoft. But the trade-off there is that market share means most companies are using AWS, or a lot of them are using hybrids too. But like AWS has the most jobs, but there's way less competition in the Azure space, to be honest. And so I think it would give you a leg up to learn it. Cloud concepts are transferable. If you go learn Azure, it's not going to be a big lift to learn AWS or to learn Google Cloud Platform. It's the same stuff with different names and a different way to access it, but the concepts are all the same. That's the last piece. So there's a lot of things on here. You can see how there's tons of tools on here, and there really aren't a lot of tools on here. This is nothing. This is a joke. It can be overwhelming when you look at that tool stuff. And start looking at all the options you have inside of each of these categories. I would take a look at this, follow this, learn infrastructure as code and cloud stuff first. Pick yourself up, learn some CD tools. Jenkins is probably the biggest one. I would stick with Circle CI, Travis CI, just because it's easiest to hop into. Learn programming language, and you can pick up the rest as you go. But learn how to talk about the concepts, learn how to talk about the stuff. Pick up the concept. Don't when you're going through tutorials or something, don't worry about the syntax of this command. You don't need to, that is not what you need to know. I Google through 90% of my day. But I know the concepts. I know what I'm trying to do. I know what it is I know the goals that I need to achieve. So you don't need to you can find the syntax. Everyone's like, oh, what if you don't have the internet? If you don't have the internet, you don't have a job. So you're not working that day if you don't have the internet. So it's a fair question. But there are a select few industries where that may be the case, but 99.9% of the time, you'll have the internet and you'll be working and understand these concepts, understand why infrastructure as code is important, understand what you're doing with it, understand what you can do with a programming language. Learn how to program, but don't spend all your time learning all the syntax and programming language. Learn what you can do with the programming language. Learn the type of things you can automate with Python. Learn how you would use infrastructure as code to set up a web server or set up your networks. Like the concepts are much more important than the actual implementation.
So, out of all of this, the last question for me is, and also, which one of the Pokemon characters, fits into the characteristics that you actually like in
Ditto. That's easy. Pokemon called Ditto. Ditto can take the shape of whatever Pokemon is in front of it or that needs to. And again, we're talking about that iteration. We're talking about that feedback loop, like being able to pivot, transition, do things that work for you is great. But that flexibility is what you need here. Like in no point in this process should you go in and grab one of these tools and make your best guess about which one to use. No point should you ever hop in and be like, we're going with this, no matter what, we're not moving off of it. There should always be room to do something that works better for you. That's the goal of it. Like short iterations, short goals. Everything doesn't need to be out here. Shoot for a goal, reevaluate. Did this work for us? Is this a good thing for us? If it's not, why not? Do we make this one that we have better? Do we just switch to something else? So definitely Ditto, because it's got that flexibility.
Thank you guys for coming through. Next week is July 4th, and we're not doing anything, so enjoy. So if you're gonna hang out, we have a social channel, it's like in there. If you're gonna allow you to know people to come. The week after that, July 20th, is our 2nd year anniversary, and so you can come. You don't have to be definitely invite your friends to come over. You can students from our course, like whatever. We'll put more information out on the Slack channel. But thank you so much, Aaron, for coming to this presentation, and thank you also.
Sorry I was late.
Thank you.
I know. You should come down. Trying to get in.
So
So you get the little delicate one, you know, and it catches the light, like, like a 5-day week.
Absolutely.
We gotta.
I feel like you used to go to something called
On the third. Thank you. You're like, come.
I